Okay, so in this lesson, we are going to talk about ions. So far, we have kept talking about neutral atoms, atoms that have the same number of protons as they do electrons. But ions are very different. An ion, as you've seen this in the notes, I'm just going to kind of go over it real quick. In order to become stable, atoms have to have 8 valence electrons. It's called the octet rule. Now, there are exceptions. For example, helium can only have 2 valence electrons max to be stable. But that's because it's in period 1. When you guys learn from talking about the periodic table, the period, which is the rows, tell you how many energy levels there are. And because helium is in period 1 energy level, it can only hold 2 electrons max. But that's irrelevant. That's one of the exceptions to the rule. But typically, for all the other elements, for the most part, in order to become stable, they need 8 valence electrons, called the octet rule. In order to do this, you have to lose or gain electrons. Now, here's the thing though. When you lose and gain electrons, you become an ion. Basically, it's anything with a charge. It can be one atom with a charge or a group of atoms with a charge. An ion is made only by gaining and losing electrons. Because remember, you can't gain or lose protons. If you gain and lose protons, you change the element. If you gain and lose neutrons, that doesn't do anything. Neutrons don't have, all that does is change the mass. It makes a new isotope. But if you change the electrons, you're actually changing the charge. Now, if there are more protons than electrons, and the only way to have more protons than electrons is by losing electrons. If you lose electrons, you become positive because you have more positive protons. And that is called a cation. Very important word, cation. And I always remember cations as positive because I think of the T as a plus sign. So just for an example, let's pretend we have a neutral atom of 5 protons, 5 electrons. 5 protons, 5 electrons. It's neutral. But now let's get rid of 2. Let's get rid of 2 electrons. So how many electrons are there? There's 3 electrons. But now that atom, specifically boron, has a +2 charge because it has 5 protons. Think of that as positive 5. In fact, let me get my writer here, bring that down. So 5 protons, that's like saying positive 5. There we go, this is really hard to do with the mouse. And 3 electrons is like saying negative 3. Well, what's positive 5 and negative 3? Clearly it's negative 2. Okay, wow, I just said negative 2. It's positive 2. So a +2 charge. Wow. Bad. Smack my hand on that one. Okay. Again, sorry. When you lose 2 electrons, okay, now you have 3 electrons total. Positive 5, negative 3 makes a positive 2 overall charge. So when you lose electrons, you become positive. On the other hand, I gotta move this over. I don't know if I can. There I go. I'm flying! When there are more electrons than protons, however, because you gain electrons, then you become negative. And that's called an anion. And that's easy to remember because of this. An anion is a negative ion. A negative ion. Anions, a negative ion. So again, go back to the example we said. Let's pretend you have a neutral 5 and 5. 5 protons, 5 electrons. But then you decide, well, you don't really decide, but then you magically gain 3 electrons. So now you have a total of 8 electrons. Well, it's like math. 5 protons is a positive 5. 8 electrons is like a negative 8. Now, if you add those together, you get negative 3. So it just goes to show you that when you gain electrons, you become negative. When you lose electrons, you become positive. And typically, however many electrons you gain, that's what, however many electrons you gain, that's what negative you are. And however many electrons you lose, that's what plus you are. Typically, not 100% of the time, but typically. A visual to this. Here I have, I got to move my face. I'm going to fly. Whoa, flying. Okay, there we go. Here I have a sodium. I know it's sodium because it has 11 protons. 11 protons. I have 12 neutrons, so the mass number is 23, so this is your typical sodium, and it's neutral. How do I know it's neutral? Because look at the charge, it's 0, and you can tell because it has 11 electrons, 11 protons. But this is not stable. How do I know? Because if you look, it needs to have 8 valence electrons. Valence electrons are the electrons in the outermost shell. It needs to have 8. Well, there's 2 ways to get to 8. Either you can add electrons or you can get rid of electrons. Now you're going, what? By getting rid of electrons, how does that give you 8? Easy. I don't mean 8 overall electrons. I mean in getting next to the closest 8 subshell, if you will. And you're probably going, what's he just talking about there? Well, let me show you. So sodium has 11 electrons. It has 2 in the first energy level, 8 in the second energy level, and 1 in the third energy level. So the question is, what's easier to do? Do I add 7 electrons to each of these to fill up the outside valence electrons? Or do I simply take 1 away? And if I take 1 away, then there'll be 8 valence electrons down here then, because these will be the new valence electrons. Because again, valence electrons are the outermost electrons, but if I get rid of this, those become the outermost electrons. So what I always tell kids is, what's easier to do? Move 7 steps or move 1 step? Clearly, moving 1 step is easier. So if I take 1 electron away, now I have 8 valence electrons from underneath, and it's stable. Now, because I took 1 electron away, look what happened to the charge. It's plus 1 because there are 11 protons, 11 positive protons, and 10 negative electrons. 11 positive 11 plus negative 10 is plus 1. So again, I just want to show you that. Watch the charge specifically. When it's neutral but not stable, I need to take an electron away. When I lose 1 electron, I now have a plus 1, and that is a cation. Another way of showing that sometimes is with symbols. So they use what's called an electron dot model. So an electron dot model is you do the symbol. Sodium is Na. Again, this is really hard to do without the smartboard, but whatever. Na. And then you go to the periodic table. Let's go to that periodic table. There it is. So if you remember, when you guys did your notes and all that stuff about the periodic table, the periods tell you how many energy levels there are. So sodium has 3 energy levels, and it's in column 1. It's an alkali metal. Remember, this number right here, the 1A, the 2A, every periodic table is slightly different. Let me see how this one works. Oh no, can I slide over? There it goes. Slide up, slide up, slide up, slide up. Okay, they do those. I'll go by the Roman numerals. The 1A and the 2A. This 1A, that number 1 tells you how many valence electrons there are. How many valence electrons? So when I draw this, in fact, every element, alkali metal and hydrogen, will have 1 valence electron. So when I draw this, I'll put 1 dot. So that means it has 1 valence electron. And there we go. Cool. Now, go back to full screen on this. The goal is, let me get rid of you. There you go. The goal is, again, you want to have 8 valence electrons. Well, sometimes I say whatever, 8 or 0. And when I say 0, I'm talking about the 8 valence electrons that are underneath the old valence electron. So again, if I did sodium, whoa, what just happened there? Let's erase that real quick. Doo-doo, there we go. I gotta do pointer. There you go. So basically, if you did the electron dot model, it's like showing only that it's sodium and it has this one valence electron right here. But what you don't see in the dot models, but sometimes they use them, is there's 8 valence electrons underneath. But again, if you get rid of it, I'm going to do that here, you have 8 valence electrons. So what I'm going to do is I'm going to get rid of this valence electron. Ooh, that was too big of a erase, but that's all right. Let me go like that. There we go. Boom. Back to sodium. Now, when you get rid of that electron dot, it now is an ion. And because it lost an electron, it's a +1 charge. You got to show that. How? Basically, you just write Na, then you put a +1. +1. There you go. Sodium. Okay, let's do another element. Gotta remember, it's on massive eraser mode. Put it on medium. There we go. Let's go back. Let's do oxygen. Okay, so I gotta get rid of some protons then. I'm going to get rid of some of these electrons. Proton, goodbye. Proton, goodbye. Oxygen has 8 protons. There we go. I'm going to get rid of some of these neutrons. In fact, I'll make it a typical oxygen, which has 8. There we go. 8 electrons, 8 protons, 8 neutrons. It's a neutral atom. But it's not stable, because if you look, there are 6 valence electrons for oxygen. There's 6 of them. And you know it's going to be 6, even if you didn't know that. You could always find out by looking at the periodic table. If I go to the periodic table, oxygen is in family 6A, 6 valence electrons. Ah, clever, clever. Now, question, what's easier to do? Is it easier to get rid of these 6 electrons to have this valence stable set? And I know you're like, wait a minute, there's only 2 valence electrons there. Yeah, but because the first energy level can only have 2, it's like 8 in a way. It's a full It's a full energy level, but regardless. What's easier to do? To get rid of these 6 or to just add 2 more electrons? Clearly, it's easier to take 2 steps than 6. So if I add 2 electrons, now I have 8 valence electrons. I have a full octet. But because I gained 2 electrons, I gotta have a -2 charge now, which you see right here. Okay, boom. It's -2 now. If I was to do a dot model for that, there's oxygen, somewhat. Okay, it has 1 valence electron. Technically, you have to do 1 valence electron per side first. 1 on the top, 1 on the right, 1 on the bottom, 1 on the left. Then you can start doubling up. So there's 1, 2, 3, 4, 5, 6. And so I say, hey, what's easier to do? Erase all 6 of these or add 2 more valence electrons? Well, it's just easier to add 2 more valence electrons. See? Boom. Boom. Now you have 8. But how do you show that? How do you write that as an ion now? Well, you would write that as oxygen with a -2 charge because it gained 2 electrons. So again, ions, atoms with a positive or a negative charge. If they're positive, it's specifically called a cation, and you become positive by losing electrons because you got rid of negatives. If you're an anion, you're a negative ion, and you become that by gaining electrons because you gain negative numbers. And I do believe that is all for this lesson here. All right, guys, take it easy.